In this video, I will be doing exercise 8.39, which reads Jack, mass 59 kilograms, is sliding due east with speed 8 meters per second on the surface of a frozen pond. He collides with Jill, mass 42 kilograms, who is initially at rest. After the collision, Jack is traveling at 5 meters per second in a direction of 34 degrees north of east. Ignore the friction. So part A asks for what is the direction of Jill's velocity after the collision, which we can't figure out until we figure out part B, which is the magnitude of Jill's velocity after the collision. So we go down here. I listed all my knowns. So Jack's weight 59 kilograms, his initial speed 8 meters per second, Jill's weight 42 kilograms. Jill's initial velocity, which is 0 meters per second, and then Jack's final velocity. We found out we already have the magnitude, but we needed to find each of its exponents. So we found that x was going to be 4.15 meters per second, and then the y component was going to be 2.8 meters per second, which we found out by putting 5 cosine 34 from the 5 meters per second at 34 seconds, and then 5 sine 34. So then we move over here, to which I already have the equation set up in component form, since after the collision both stray away from one direction, move in two directions. So then right here I have the equation in which the equation for elastic collision when object starts from rest, which is that equation right there. So I have already taken out the information for B to make it simpler for us, and then from this equation we just express it so we are able to find the x velocity of Jill, her final velocity at x. So right there we rearrange the equation, and right here we plug the numbers in for x. So since we're originally moving since Jack is originally moving in the x direction, we are able to put in those values into the equation we got up here, which eventually leads us to get 5.41 for Jill's x velocity. And then we solve for y velocity, which there was no motion in the y velocity for Jack, which is why there's a 0 right there. And then, but afterwards, he does have y velocity after the collision, which gets us to negative 3.93 for Jill's velocity in the y direction. And then we find the magnitude by squaring both those squaring both those numbers, and then finding the square root of the addition of those two, which equals 6.69 meters per second. And then in order to find the angle, you just tangent inverse the y on top of the x, which gets us 36 degrees. And that is exercise 8.39.